Hello dear students, welcome you all. I am Meghamala, Working Assistant Professor from Electronics and Communication Department, Institute of Aeronautical Engineering. And today I am going to discuss about the problem solving on behavioral modeling. So far we have discussed about different various definitions and terminologies from the behavioral modeling, as it is one of the modeling style in the Verilog. So now we will discuss about the problem solving, few codings in the behavioral modeling, using behavioral modeling. So before we go further, let us discuss something about the statements in the Verilog. Are very useful construct that generate synthesizable codes during elaboration time dynamically. So here, as we are now concentrating on the problem solving or else the designing of a few modules based on the behavioral modeling, okay, based on the different structures, behavioral modeling, using behavioral modeling, we have to go through different statements, right? So those statements will be considered as per the constructs that you are considering. Okay, this is what it says. A very full construct, it generates some code. Okay, that code is all obviously the synthesizable code, and during elaboration time dynamically. Then the simulator provides the elaborated code to generate blocks. So here the simulator code, okay, in order to synthesize, after synthesis process, we need to simulate the code. So in order to simulate the code, the simulator will provide a code. That code is nothing but the general block code. Okay, so in that code is all about the to generate, okay, generate block. So it provides the facilities. So this generate block, the code which is obtained from this simulator, it has some facilities. So let us know what are the facilities. This generate block, it provides, or else it gives the facility to generate multiple module instances or code repetition. So this generate block, what it does is it will just generate, okay, it generates the multiple instances, okay, in the module, multiple module instances or code repetition. We can see the code will be repeated. Why the code is repeated? Because multiple instances are considered. Okay, so the multiple module instances are generated. So as the multiple module instances are generated, so obviously the code is generated, or else obviously the code is repeated. Then conditionally instantiate a block of code based on the Verilog parameter. So conditionally instantiate a block code. Okay, a block code is instantiated conditionally using the conditional statements, if else and all. And so that conditionally instantiate a block of code based on the Verilog parameter. So based on the parameters which are described from the Verilog, that Verilog, it will instantiate the blocks. Okay, it's instantiate the block of the code, and then the parameter is not permitted in the generate statement. So as we are considering some parameters from the Verilog, and those parameters can be obviously considered in the code which is pertaining to the conditional statements, and we are saying that parameters which is obtained from the Verilog is not permitted in the generate statement. So it is not permitted in the generate statement. Then it basically provides control on variables. Okay, so this generate block, it basically provides controls. It controls on variables, it controls on functions, it controls on tasks and instantiation declaration. Okay, so this generate block, it takes control over many things. Okay, so we can say here generate blocks, or else task, functions, instantiation declarations, and as well as the variables. And a generate block has been written within generate and end generate keywords. So as we are discussing about the generate block, so this generate block can be observed by using the variables, or the parameters, and the parameters can be obtained from the Verilog library. So here, if your code you are writing with respect to the generate block, then your keyword must be, or as a code must contains the starting line of the code should contains a keyword, and that keyword goes with the keyword called generate. Okay, the code should start with the generate, and after generate, after the different statement, it should end with end generate. This is how you have to write the code. This code is pertaining to the generate block. And now we will see what are these generate block and types of generate blocks and also data types and functions and tasks. So here, coming to generate instantiation, as I said you, this generate block. So this generate block, it provides some facilities. So that facilities, it could be on the instantiation, it could be on the what do we say? It could be on the declaration, function, task, variables. It could be on the variables, it could be on the functions, and it could be on the task, and also instantiation declaration. Isn't it? So now we will see the type of generate instantiation. Now in the generate block, we all see these are the variables that it can consider. And now we will see the types of generate instantiations. So in the generate instantiations, we'll come across the modules, okay, and also Verilog get primitives, okay, Verilog get primitives, continuous statements, initial and always blocks, and user defined primitives. So these are the few instantiations whenever you are considering a generate block code. Okay. So now we will discuss about what is a data type. So what is this data type means? Data type has the integer, real, net, reg, time, real time, and event. So here these are the few variables. Okay. So these are the few variables and these variables are meant to instantiate if you are writing a code. Sometimes these data types, when you are writing a code, the data types follows with net, and sometimes it follows with reg 3:0, isn't it? Sometimes it defines about the delay, and delay is mentioned with the hash code. So d hash 20, like that, and then the event goes on. So these are the few data types where you can write your code in terms of the generate block. Okay, as I discussed, we can make use of the variables, we can make use of the functions, we can make use of the task, and also we can make use of the instantiation declaration. So using these data types, as we said, new data types are nothing but the variables. So using these data types, we can able to generate a code based on the generate block. So here, for example, if you're writing your code in terms of reg, right? So if you're writing your code in terms of reg, and that too is with respect to the generate block, and then your code should start with generate, okay, generate or else generate, and then it should start with module, and then it should start with the inputs and the outputs and the statements, and comes with the event, end module, and end generate. Okay, this is how your program or else a code should written. Then coming to the functions and tasks. So as I said you, functions and tasks are also comes under the category of variable. In the generate block code, you can make use of these functions and tasks as well. So here we have an important note to be remembered, saying that functions and tasks are not allowed within a generate loop. So if your code, obviously when you are writing your code in the generate block, then here it says that the functions and tasks, they are not to be allowed to write in the generate loop. Okay, but they are allowed in the generate block. So they are not allowed in the generate loop, but they can be allowed, or else the functions and tasks can be allowed to write in the generate block. Okay, but the important thing to be remember when you are writing your code in terms of generate block, remember that your code in the generate loop, you cannot mention the tasks and functions, whereas in the generate block, you can easily mention the tasks and the functions as well. Then, now below module items or declarations, they are not allowed within the scope of generate block. So here in the generate block, you cannot declare, okay, you cannot declare the module or items. So what are those modules and the items are? a port declaration like input, output and in output. So in the generate block, you cannot declare the input, output and in output declaration. And also within the generate block, you cannot also specify the block and also the parameters and the local parameters. The parameters, the general parameters and as well as the local parameters as well cannot be declared in between, or else in terms of, or else cannot be allowed in the, when you are writing the code in terms of the generate block, right? So now we will see the methods. Okay, methods to write the generate statement. So if you when we are not supposed to write our codes in terms of all these things, then what are the various methods that we can follow, or else what are the various methods that we can that they are allowing us to write our code in terms of all these things? Is here we have few statements, or it's a methods to write the generate statements. So what are those methods? Is generate loop is one method and the other is generate conditional. So coming to generate loop, so we will discuss in depth, we will discuss what is this generate loop and how are we going to write our code in terms of all these declarations in terms of the generate loop. Now the generate loop is similar to for loop. Okay, it is similar to for loop, and see here it is similar to for loop, but it uses genver keyword as a loop variable. So here as we are discussing about the generate block, in the generate block, for loop, instead of for loop, as when we are writing the code in with respect to the for loop, instead of for loop in the generate block, we can write the generate loop as well. Okay, if you are writing the generate loop, then your keyword should goes with as genver. Okay, genver is a keyword as a loop variable, and then the genver keyword is only used during the evaluation of generate block. So genver is a keyword. When we are using this genver as a keyword, this genver keyword is used only when you are writing your code in terms of generate loop, right? So when the genver keyword is used, that means during the evaluation of generate block, when you are evaluating the generate block, then genver keyword is needed or necessarily it is observed then, and does not exist during the simulation of the design. So when you are simulating the process, this genver keyword will not exist. Okay, and this generate keyword is used only for the evaluation of the purpose. So this genver is a keyword and it is used only in terms of evaluation, and it does not exist, okay, until the simulation is done. Until the simulation is done, this genver keyword does not exit. Okay, it does not exit. Then generate loop, it needs to be used by generate loop. So however, generate loop generate loop consisting of a keyword called genver, and this genver keyword is helpers, or else it helps during, or else it is used when during the evaluation process, and also it will not exit. Okay, it will not exit until the simulation is done. Then it is used only in terms of the generate blocks. And also the generate loop, it provides flexibility. Okay, it's one of the advantages. It provides a flexibility to reduce code lines by replacing repetitive statements to a single statements like for loop. So here this generate loop, it provides very flexibility. Okay, the flexibility we can observe when you are using this generate loop, genver keyword by using, and it will reduce, okay, this generate loop, it reduces the code lines, it reduces the statements by replacing repetitive statements to a single statement. So sometimes we observe like there are the repetitive statements S1, S2, S3, and sometimes we will observe S1, S2, S4, S5 like this. And now in among these statements, we will see that S1 is repetitive and S2 is as well repetitive, right? So what this generate loop will do is, this generate loop, as it is a flexible to consider, and so it reduces the repetitive statements. So it will take only one statement which is pertaining to S1. So as we know that S1 and S2 are repetitive. So here, as these are repetitive statements, what this generate loop will does is, it considers S1 only once and as well S2 also only once. That means it just reduces the repetitive statements into a single statement, like for loop. As we know that in the for loop as well, if the statements are repeating, what we do is we just consider all the repetitive statements together as a one statement, and then we will simulate it. The same will observe in the generate loop as well. Then similar to a for loop, generate loop also can be nested, okay, with different genre as a index variable. So in the for loop, we say that what is a for loop? For loop statement says that until and unless if your condition is true. Okay, until and unless if you are observing your output condition, that means if the condition true is observed, then only the for loop will execute. Till this extent the for loop executes. And after the truth table is observed, then for loop exits. Okay, for loop exists. So the same it goes with the generate loop as well. So what is this generate loop? As saying that it is also can be a nested. Okay, what is a nested? The repetition of the statement. The repetition of the statement, if it is go on repeating until and unless if t is observed. For example, in a case, for example, for t is equals to 4. So for t is equals to 4 times until the fourth time, first time we got, second time the statement repeated, third time the statement repeated again, and the fourth time we got the statement as true. So what happens here? The for loop it exit, right? So until the truth observed, the for loop will exit. So the same way, this is nothing but the nested, right? So the nested. So here the generate block is also can be a nested, and with differ genre as a index variable. So when the for loop is getting repeated, what happens is in between we are coming across, or else we are considering the keyword must to be present, or else instantiation of the keyword in between the statement is considered, right? So here also in the generate block, when these blocks are repeated, or else when the loops are repeated, then what happens is in between we can make use of, or else we can write the genre keyword. Okay, genre keyword is to be mentioned or else instantiated in between the statements. So that is what the generate loop is. We can see the similarity between the generate loop and as well as the for loop. Now, so this is an example based on the always block. Okay, always block, we know that in the out of 4 modeling styles in the behavioral modeling, we are using a keyword called always. Right, always at the rate is a keyword that this is a basic prominent keyword when you are modeling your code in terms of behavioral modeling. And now we will see in this example always block inside generate block. So inside generate block, how we are going to use this, or also how we are going to implement this always block. This is nothing but say genre k. So we know that genre is a keyword, right? Genre is a keyword. Okay, genre is a keyword. Generate for k is equals to 0, k less than 4, k plus plus, then begin. Then this is also a keyword. This is a keyword pertaining to the behavioral modeling. So in the behavioral modeling, as we are discussed that always at the rate is a prominent keyword that we must use. So here this example pertaining to this generate block, we are pertaining to this this is a generate keyword for the generate block, and then we are introducing this behavioral modeling keyword always at the rate. So positive edge clock begin, then value k, ak and bk, right, and generate, right? So as we are starting with generate and generate, then this code expands to, so how we will see this code is expanded to always at the rate edge clock. We have a clock signal with a positive edge. So we all know this positive edge clock signal is nothing but from 0 to high level, right? This is a positive edge clock. And then if it is from 1 to 0, and we call this as a negative edge clock. right? So in the flip-flops, when you have clock signals, so we are considering the positive edge and as well as the negative edge clock. So now in this example, the code, whatever we have written, the output that we can observe here as always at the rate positive edge clock, begin value 0 to 3, right? So here how many we have? 4, right? K must be less than 4. So for value 0, A and B as 0, 1, 1, 2, 2 and 3, 3 like N. So this is a basic example that we can understand how the generate block is making use of the behavioral modeling style. That means we have written the code in terms of generate block, and also we have written the code in terms of generate block by using the behavioral modeling style. In the behavioral modeling, we have make use of this behavioral modeling and we have written the code. This is nothing but the generate code, right? And now we will see a few more examples regarding this generate block. So before we go that, we know this, what is this generate conditional? So what is this generate conditional is, generate block allows conditionally instantiated using if-else-if construct and also the case keyword. So here, as the name indicates, a general conditional. So as the name indicates that it's a generate conditional. So what we use is the generate block. It also allows the conditionally instantiated using if-else-if construct and as well as the case keyword. And now we will see the example based on if-else. So if it is if-else, then obviously it must be generate if-else. So in the below example, the example that we consider now, it is based on the parameter selection lines. Full adder or half adder design is instantiated, and by default we see the parameter selection to be 0. Okay, so the parameter that we have considered is selection, and in the initial, by default this parameter is always considered to be the 0. That means full half adder will be instantiated. When the selection line is 0, half adder is instantiated. And from the text bench code, parameter selection 1 is passed to instantiate full adder. So in the text bench code, okay, in the text bench code, we see when the selection line is 1, then we see that the instantiation of full adder is to be observed. Then in order to display, okay, in order to display the output, so display cannot be used within the generate block without the initial block. So here, in the normal other codes, when you are using any sort of modeling styles, we see that in the test bench, okay, in the test bench we observe the output, right? So in order to observe the output, obviously we will write a keyword named as display. So but whereas in the generate block, we see that the generate in the display keyword, or as in order to display the output, it cannot be used within the generate block without initial block. Otherwise, it throws an error display in an invalid generate scope construct. So for example, if you are in the code, in the test bench code, if you are mentioning anywhere with respect to display, right? If you are mentioning anywhere with respect to display, then you will get an error saying that it is an invalid generate scope construct. Why? Because in the generate block, nowhere display is mentioned. Okay, the display in the text bench code, the display is not mentioned in the generate block code. If you are writing your code in terms of display, then obviously you will come across an error base. That error is all about the invalid error, that is with respect to the scope construct, generate scope construct. Then see, this is an example. So in this example we'll see okay, so this is an example generate case. So this is one more example, as we say that if else in the conditional block, in the conditional generate block, we see if else and also the case keyword, using the case keyword. And previous example we have considered for if else, and now we will see the case. So similarly, the above example if else, in generate block, alternatively use case statement as specified into below example. So here if you observe module half adder, okay, we know half adder is comprised of both A and B, sum and carry. So this is a half adder. And if it is a full adder, we know that A, B, C are the input, sum and carry, right? Okay, so this is adder. Inputs are A and B, output is sum and count. And assign is a keyword. Sum and count, which is A or B, A and B. So here we are instantiating with respect to the gates. So that means A and B. Okay, A and B and A or, right? Then assign some A or B and XOR B. Sorry, this is an XOR B and this is A and B and this is OR. So this is nothing but here you will observe the sum and here you will observe one more gate and here you will observe the carry. This is sum and the combination of one more AND gate. This is Cout, sum, right? So this is how the execution takes place. This is how the, what do we say? This is nothing but the structure of a particular half adder, full adder. So here assign sum count A or B, and after in this port list again we are initializing separately. So assign sum and assign count. So end module. Then this is all about the half adder. And now we will go for the full adder. Full adder, input ABC in and output sum and Cout. Then assign sum and Cout. How? A, B, C in. Okay. A, B, C in. And then A and B. Here you will see one AND gate. Here you will see an AND gate. And here you will see A, B, C in as OR gate, XOR gate. And then A and C in as AND gate as well. A and C in as AND gate. Here B and C in as AND gate. And then here A and B in as AND gate. And here A, B, C in as OR gate. Okay. Then after assigning separately, we will be assigning separately. That is with respect to the sum and with respect to the Cout. Then end module. So till this we have completed with the full adder. Then now this example is all about the generate case, right? By using generate case, how can we represent, or else how can we model a structure based off half adder or full adder? Then now module generate if X. Okay, using the if else generate block, module generate if else parameter selection is equals to 0. I said when S is equals to 1 in the previous thing, S is equals to 1 is a half adder. S is equals to 1 is a half adder. S is equals to 0 is a full adder. S is equals to 0 is a full adder. S is equals to 1 is a half adder, right? So after this, we are saying that selection is equals to 0. When selection is equals to 0, it means it's a half adder. A, B, C in, S out. Then generate case. And now we are making use of case. If, else, and case. By making use of these two statements, we are able to write the code. So once we are done with if, and then we are moving forward with the case. Case selection based on the selection lines. If it is 0, we say that it's a half adder. If it is 1, it is a full adder, right? Case. Then end case, end generate, end module. So this is how the code with respect to the generate block is to be written. Always remember that in the generate block, if you are supposed to write your code in terms of generate block by using conditional statements, that is if else and the case statements, then the first and foremost thing in your code you must write is you should start your code with the module. Okay, why? Because module is a basic keyword in the Verilog, right? So module represent half adder separately and then full adder separately. Okay, represent all the terms pertaining to the input and output in the half adder separately by using a keyword. Okay, if you are writing your code in terms of data flow, or else gate level modeling, then you must use a keyword called assign. Okay, if you are using your keyword always at the rate, then that it's nothing but the behavioral modeling. So mention, you have to be clear in your code when you're writing your code. If you are supposed to write your code in terms of gate level or data flow or gate level modeling. Then use a keyword called assign. Okay, assign the output properly, okay, with respect to the gates that you are using by using the operators. And then finally ending the module. Now you have to concentrate on the code with respect to the generate block. So in the generate block, what sort of conditional statements you are using? For example, if you are using only one conditional statement, if else, then you should start if parameter by using the selection lines. Obviously, when the selection line s is equals to 0, it means that the full adder, half adder is going to be implemented. When the selection line s is equals to 1, right? When the selection line s is equals to 1, then full adder is going to be implemented. So this is how the code is to be written. This is all about the example or else the coding part with respect to the behavioral modeling. So in the behavioral modeling, by using behavioral modeling, behavioral construct, okay, we have discussed about something about, see here, output. So if you observe the output here, for example, for this particular example, the output goes like this, full adder, right? A is equals to B is equals to C. A, B, C is 0, 1, 1. Then the sum is 0, C out is 1. Isn't it? When both the inputs, all the inputs are 1. When all the inputs are 1, then sum is 1 and count is 1. When A is 1, when any one of the input is 0, then what happens? When any one of the input is 0, then C out, the sum is 0 and C out is 1. So this is a basic example or else a simple example that I can give you. If you that I can give you that in order to experience it or else in order to analyze it properly with respect to the generate block by using the conditional statement. So here we have used conditional statement as if and also the case statements. Okay, case conditional statements. Then also we have discussed about the basic rule if you are writing your code in terms of generate block. Okay, in terms of generate block, if you are writing, then Genver is a keyword that you have to observe. Genver is a keyword. So Genver is a keyword that Genver is a keyword where you have to write your code with respect to the generate block. So after Genver, you have to mention what are the inputs, what are the outputs. And if, for example, if you are using any sort of case statements, okay, then you have to mention what sort of case statements you are using. If else, sometimes if else or else case or else if and so on. Okay, then this is how you have to write your keyword. So write your code. So in this code, you are writing this code with respect to the always block. Okay, why? Because we are writing all the codes by using the behavioral modeling. So by using the behavioral modeling, all the codes have to be written. So when you are using the behavioral modeling, always at the rate is a keyword to be assigned. And also this the code is with respect to the generate block. Then you have to start your code with code by using a keyword Genver, right? So Genver keyword generate, then goes with the for loop and then end and then end generate. Okay, end generate and followingly. This code is expanded. So how can we expand this code by using? See, now we have to go with k is equals to 0, k less than 4 and k plus plus. So until 4 bits, right? So from variable 0 to 3, and this is how I'm going to represent 0. For variable 0, a and b are to be 0, a, k and b, k. Okay, for variable 1, for variable 0, a is to be 0 and b is to be 0. And for variable 1, a is to be 1 and b is to be 1. And for variable 2, a is to be 2 and b is to be 2. And for variable 3, a is to be 3 and b is to be 3. So totally 4 bits, right? So this is how we can we are going to observe or generate by using the generate block. This is how we can going to write our code in terms of behavioral modeling structure. And also we have discussed about the generate loop as well. Remember the generate loop. In the generate loop, we see that the repetitive statements can be considered to be as a single statement. This is one of the advantage. Okay, why? Because the generate loops are flexible, and so we can reduce that loops, or else we can reduce the repetitive statements into a one single statement. Okay, this is one of the advantage in the generate loop. And then these are the few data types instantiated in the generate code. Okay, in the generate block, if you are writing your code in terms of generate block, then there are the few things to be instantiated. So those things are with respect to the data types, and those things are with respect to the functions and tasks as well. Okay, and also as we have the instantiation. These are the types of instantiation, generate instantiation. So how can we instantiate? We can instantiate the modules. Okay, we can instantiate the Verilog gate primitives as well. Okay, what are the gate primitives? What are the modules that we have instantiated? Genvar is a keyword that we instantiated. SN is a keyword that we have instantiated, and all. And then Verilog gate primitives. Gate primitives are AND gate, OR gate, right, NOT gate, and all, etc. And then continuous assignment statement. Continuous assignment statements are meant for the synchronous synthesize. They they just synthesize, or the simulation can be done. The synthesizing can be done concurrently, isn't it? Concurrently, the all the steps have been done concurrently. And then initial and always block. Initial and always block, if you are based on the designing style. Okay, based on the designing style, the instantiation of the always block or initial block is mentioned. And then user defined primitives. Okay, user defined primitives are also can be considered if you're writing your code in terms of generate block. So this is all about the few examples with respect to the behavioral modeling style. I hope you all understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.